Now I've got the base function here, y equals absolute value of x, and I'm going to vary k and h. Let's do k first. Notice that as I move k up from 0, it goes up to 1, the graph moves up 1, 2, 3, 4, 5. So that's y equals absolute value of x plus 5, and it's 5 up. Put it back to 0. I'll go the other way. -1, -2. Okay, that's absolute value of x minus 5, and it's 5 down. So let's put that to 0. And now we'll vary h. H is 0. And so here is h is 5. And you can see x minus 5 has moved 5 to the right, right here. And how about x plus 5? There it is. X minus 5, or x plus 5, has moved 5 to the left here. Now let's put them both at 0. And how about we make k 3 and h 4? Where will that move? Let's do the h first. Make it 4. And that will move 4 to the right. And k3, that will be 3 up. And then the vertex is at 4 over and 3 up. And that's given by the equation here, x minus 4, absolute value of that, plus 3. Start with the graph of the base function, y equals absolute value of x. We have to move that graph 4 units to the right. So there's 1, 2, 3, 4, and that'll be the new vertex. I'll draw in the line. That's the right side. And then I'll draw the line that represents the left side of the graph. Now we have to apply a vertical translation of 3 units up. So 1, 2, 3, and we'll just redraw the graph. Here's the right side, and then the left side. Now check a few key points. 0, 0 should be 4 right and 3 up, which would make it 4, 3. 2, 2 should be 4 over, which would make it 6, and then 3 up, make it 5, so that'd be 6, 5. -2, 4 over would become 2, and then 3 up would become 5. So we've checked 3 points, so the graph looks good. I want to graph the function y equals the root of x plus 3 minus 4. So I'll start with my base function, y equals the square root of x, and I'll move it 3 to the left because of the x plus 3, and then 4 down because of the -4. I've replaced x with x plus 3, that moves it 3 left, and I've replaced y with y plus 4, that moves it 4 down. Of course, you can see that it's 4 down on the right side there. So let's take a convenient spot. There's 0, 0, 3 left, 1, 2, 3, 4 down, 1, 2, 3, 4. So that point will go there. There's another good spot, 1, 1, 3 left, 1, 2, 3, 4 down, 1, 2, 3, 4. So that spot is translated there. There's another good spot, 3 left, 1, 2, 3, 4 down, 1, 2, 3, 4. And the last one over there, 3 left, 1, 2, 3, 4 down, 1, 2, 3, 4. So there's enough points to try and draw that line down, try and make it look like a square root through those 4 points, and there's our translated function. Alright, we have our base graph of y equals x squared, and we want to translate that to y equals x minus 4 all squared plus 1. When I replace x with x minus 4, the graph moves 4 to the right. And you can see that it's going to move it up 1. So all I have to do is take some convenient points. Here's 1. I'll move it 4 right. 1, 2, 3, 4. And then 1 up. So there's where our vertex will be. Here's a good spot. 4 right. 1, 2, 3, 4. And then 1 up. Here's 1. 1, 2, 3, 4. 1 up. And then we'll take these last two here. 1, 2, 3, 4. 1, 2, 3, 4. And 1 up. And then we just draw the parabola through those points. Now we're given the function shown on the graph, f of x, and we're asked to sketch the graph of f of x plus 3 minus 2. Now there's no function formula for this graph. We have to figure out what to do. And from the principles we've learned, you should be able to see that the graph will go 3 left. I've replaced x with x plus 3. That makes it move 3 left. And then 2 down. So we take each point and move it 3 to the left and 2 down. It would be a good idea for you to pause this slide and figure out the coordinates of the new points. Now the point negative 5, negative 2 becomes negative 8, negative 4. And then negative 3, 5 becomes negative 6, 3. So let's draw the line connecting those 2 points. Now the point C becomes negative 3, 3. D becomes negative 1, 0. And E becomes 2, 5. So let's add the lines that connect those points, and we finish translating the function. If the point 3, negative 4, is on the graph of the function y equals f of x, determine the new coordinates of this point on the function y equals f of x plus 4 plus 2. When I replace x with x plus 4, the graph moves 4 points to the left. And then, of course, it will move 2 up. So let's start at the point 3, negative 4. Count 4 left. 1, 2, 3, 4. And now let's go 2 up. 1, 2. So the new coordinates of the point are negative 1, negative 2. Now we have the function f of x equals x squared, that's in blue, and we have to determine the equation of the function g of x, which is in red, and we want to put it in the form y minus k equals f of x minus h. So let's look at the vertex of the original function. It's at 0, 0. And notice that the vertex of g of x is at negative 4, negative 5. Now pause the slide for a second and see if you can figure out the equation of the new function g of x. Now the function g of x has moved 4 left, so replace x with x plus 4. It's also moved 5 down, so we replace y with y plus 5. So the equation of the translated function is y plus 5 equals f of x plus 4. In terms of the function x squared, we could write y equals x plus 4 squared minus 5. Notice I've moved the 5 over to the right side. Now once again we have to determine the equation of the translated function, that's the red one, in the form of y minus k equals f of x minus h. Notice that we don't actually have an equation to deal with, just these graphs. So the graph has been translated 4 units right. So that means we replace x with x minus 4. It's also been translated 9 units down. So replace y with y plus 9. So the equation of the translated function is y plus 9 equals f of x minus 4.